Good morning, grade 3. Hope you're fine today. I'm gonna start in the science subject, lesson 3, chapter 11, page, let me show you the page 452. It's about work and energy. Let's please open together page 454 and start with the first question. What is work? Let's please highlight together before I start explaining the meaning of the word work. Work is done when a force moves an object or changes an object's motion. So, work happens whenever you do motion to a certain object. You move it, you change its place, you change how it looks, you put it up, you put it down, you change its position. This means work is happening. Okay, so in order to have work, a certain motion has to happen. Okay, let me show you here certain examples on my laptop. For example, here, if you take a look at this boy is pushing a wagon. This wagon is changing its position, okay? So, since this wagon is changing its position, a certain work is happening. The same thing here for a swing. The girl is pushing this her friend or this girl on the swing. And the swing's place is changing whenever the girl is doing certain work. So a work is happening here because the swing's position is changing whenever she does the work. Okay, so please, you have to know that work happens when when the object itself that we're doing the work on is changing its position, or it's moving, or it's doing a motion. Okay, like picking up a book is a work. Whenever you pick up the book, you're changing its place, you're doing a motion on this book, so there is a work occurring. When this book falls from the table to the floor, there is a work that is happening. What's leading this book to fall from the desk to the floor is called gravity. Okay, look at my pencil here. This pencil, I'm not doing any force on this thing, but just I'm leaving it. The pencil will go down. So the gravity is pushing the pencil down. So the gravity here is the one, or is the thing that's doing the work. Okay? Now, take a look at this example. Pushing on a wall is not a work. As much as I push a wall, the wall will not change its place. Okay? So, since there is no motion, and since there is nothing moving in the wall, I'm not doing any work. Okay? So please, you have to know, work happens whenever the object moves or whenever the object is in motion. Okay? So, it's not depending on how hard you push, but it depends on how the object is moving, okay? The work can be very easy or the work can be very hard. Take a look here on my example. Okay. Picking up like these boulders, okay? If I pick up these big rocks, I will need a lot of work, okay? But if I pick up small pebbles like these ones, okay, it will take less work. So it depends on how heavy the thing is. If it is very light, I will need less work. If the thing is very heavy, like this kind of rock, of course you can't hold it, but just giving an example, you need a lot, okay, and bigger work. Okay, let's please move to page 456. In this page, they are asking about what is energy. Now, please highlight, work cannot be done without energy. If you know from the previous explanation, okay, the energy is the power that we take from things, okay? We eat food to get energy, so we are capable of doing things. So without energy, you cannot do the work, okay? So energy is the ability to do work. So to do work, you need energy. These two words are connected together. Energy, it is what makes motion possible. So if there's no energy, there's not gonna be any motion, there's not gonna be any work. An object needs energy to move. When you do work on an object, you are giving it energy. So whenever there is moving objects, you are giving this object energy, okay? Now, there are two kinds of energy. The first one is kinetic energy. The second one is potential energy. Let me start with the first one. Kinetic energy, it is all related about the motion of an object. So when an object is moving, okay, like rolling, moving in a straight line, any way the object is moving in, it's called a kinetic energy. Let me show you some examples I got for you. Take a look at this arrow. This arrow is released in the air. After it is released, it is moving in the air. So since there is motion in the air, we call this kind of energy kinetic energy. Okay, so this arrow is doing work by an energy called kinetic energy. Let's take a look here. This object is crawling, or this boy is crawling down by the bicycle down the hill. Okay, so since this object is moving down, okay, so there is a kinetic energy. These two people are running, okay, so since their muscles are moving and they are moving and they are changing their position, okay, there is a kinetic energy. This car is also moving in a straight road or whatever, okay, there is a kinetic energy because there is motion. So whenever things are moving, there is or we are using kinetic energy. Now let's move to the potential energy. Potential energy is stored energy that is ready to be used. There is something, we call it stored energy. Stored energy, it means there is an energy inside this object, but still it's not in motion. Let me show you how. Here, like if I'm stretching a string and I'm stopping it here on this place, there is an energy that is stored. It means if I leave it, this string will start moving, okay? So there is a stored energy. It means the string now it's not moving, but if I leave this energy or leave this potential energy, it will start moving. So it means that whenever I'm storing this energy in an object and after a while it will start moving, we have potential energy. Like before I throw the arrow, okay, I'm stretching it, okay, I'm giving it potential energy. Then when I release it, it will start moving in the air as I showed you before. So now the arrow is not moving, but there is an energy stored while I'm stretching it, which is called potential energy. You have to know something, that whenever I'm storing energy, there is a potential energy. Whenever I release it, okay, and this object starts to move, this potential will turn into kinetic. So whenever an object starts to move, we have kinetic. Whenever we are putting energy inside an object without moving it, it is a potential energy. Okay? So, they said here, you get most of your energy from the food you eat. And even when when gasoline, wood, and food have all of these things have stored energy. When you burn them, okay, you burn the food inside your body to get energy. You burn the wood for releasing energy. Okay, so whenever the wood, for example, is burned, it's changing its shape. So after it is burned, there is a kinetic energy, okay? So please, you have to know, stored energy as potential energy will turn at the end into kinetic energy, okay? Now, let's turn to page 458. How can energy change? Energy can move from one object to another. When you roll a bowling ball, you transfer the energy from your body to the ball. So whenever you are playing bowling, for example, you are putting energy in this ball and you throw the ball. So the energy is moving from your hand to the ball. After that, this ball will hit the skittles and let them fall on the floor. Okay? So the ball is changing its motion and even the skittles are changing their motion. So the kinetic energy here, okay, is being transferred, okay, from your body to the ball, and after that from the ball to the skittles. Okay? Energy can also change form. For example, if you start rubbing your hands together, you can feel that your hands are becoming hot. Okay, so this kind of energy is changed, okay, from rubbing into changing its form from being moving into a form of heat. Okay, so in this way I explained this lesson. I know it's something new, so we are always ready to help and answer your questions. Thank you. Hi again. Now I'm gonna move to lesson 4 in the science subject, and I'm gonna talk about using simple machines. Let's please all together open page 464. And let's start with the first question, which is, what are machines? If you think about machines, you're gonna find them all around you and you're gonna use them in your everyday life, okay? So machines, you use machines every day, okay? And nowadays we can't accomplish the work we want without machines, okay? So a machine is something that makes work easier to do. Why do we use machines? Why do you think we need machines? Because obviously the work that is done by the machine, it's very quickly and it's easier to be done than doing it by our own selves, okay? So some machines help you use less force to do the work. So machines use less force to finish the work, okay? If there was no machine in our life, okay, it would take us more, it would need us more force, and it would need us more time to accomplish the job we want to finish, okay? So machines use less force to finish the work that should be done, okay? Now, let's move to page 465 and let me introduce you to something called simple machines. You have to know that simple machines are machines with a few or no moving parts. If you take a look at a simple machine, if you think about it deeply, you will figure out that simple machines, okay, have no or very few moving parts. Okay, now through the lesson, I'm gonna show you what do we mean by moving parts or few moving parts. By the way, you have to know that there are 6 types of simple machines. Okay, there's the lever, the pulley, the wheel and the axle, and the inclined plane, and the screw and the wedge. Don't panic, I'm gonna introduce each one for you. Let's start with the first kind of a simple machine, which is called the lever. Okay, so whenever you hear about the lever, you have to know that it is a straight bar that moves on a fixed point. This fixed point is called the fulcrum. Take a look here, please. Okay, I will show you the lever. This is a lever. This is an example of a lever. Whenever you see something that is connected with one point from the middle, which is the fulcrum, okay? So this is the moving point, okay? Which is one moving point. That's why it is a simple machine. So the fulcrum is the connected point, okay, of the lever. So the lever, if you think about a seesaw, the lever moves something up and the other side moves down. So the lever is connected with a fulcrum, okay, which is used to lift things up, and the other side will go down. Okay, so let's go back to the book. A lever can be used to lift something. The object lifted is called the load. So whenever an object goes up, this object that is moving on the lever, it is called the load. Okay, take a look here in the book. They used also the example of a seesaw. So the connected point here that this seesaw is moving on is called the fulcrum. Okay, the boy is doing a force down. So I said whenever there is something moving down, the other side gonna move opposite way, which is gonna move up. The object that is lifted or the object that is moving up is called the load. Okay, so this is all about a lever. It is something that is used to lift things up, okay, and there is a center of a lever which is called the fulcrum, and forces are moving in the opposite way. One is going down and the other is going up, and the one that is going up is called the load. Okay, let's move now to page 467 and let's go with, to talk about the pulley. A pulley is a special kind of a lever. It uses a rope and a wheel to lift an object, okay, up. So why it is a kind of a lever? Because it also lifts objects, okay, and it uses a rope. Take a look at the pulley here. So the pulley also, we use the pulley to lift things up. So whenever you drag this rope down, the other rope will go up. Okay, the same thing like a lever. Okay, so the pulley uses a rope. So whenever a simple machine uses a rope, it is called a pulley. Now let's move to the wheel and axle. Okay, the wheel and axle is another special lever made up of a wheel that moves around the post, which is called an axle. If you saw here in the playing area about the wheel and the axle, the wheel rotates, okay? It rotates the same way as the axle is rotating. So there is a center here, it's called the axle, not the fulcrum like the lever, it's called the axle, and they rotate in the same direction. Okay, this simple machine, if you see there is one moving center that leads to the moving other part, okay, that's why it is a simple machine, because it uses one moving part. Okay, and this kind of a machine, it is used to do rotation. Okay, Now, let's turn the page to 468 and let's talk about the inclined plane. If you take a look here in the book, you're gonna see that inclined plane sometimes is used to push things up, and sometimes it is used to push things down. So if I'm moving this thing up, it's gonna move up. If I'm pulling it from here to down, it's gonna move quickly goes down. Okay, so an inclined plane is a simple machine with a flat and slanted surface. So flat and slanted surface, it's called an inclined plane. It takes less force to push a box up by this way on the inclined plane to put it on the truck, easier, and it needs less force than lifting it directly from the floor up to the truck. So an inclined plane, okay, uses less force, or reduces the force that is needed to the job to be accomplished. Okay, so inclined planes can make work easier to do. They reduce the force you need to move an object. Okay, this is an example of pushing something up. What about pushing, for example, a ball on an inclined plane? It will scroll quickly down to the floor with less and with reduced force, okay, than scrolling it on a straight line, on a straight surface, right? Now, till now we did how many examples of simple machine? We did the lever 1, we did the pulley 2, we did the wheel and axle 3, and we did the inclined plane, which is 4, and still we have 2 things to reach number 6. Let's go to the word screw. A screw is an inclined plane wrapped into a spiral. So whenever you see a spiral look like this way, it's called a screw. Okay, so there are many things, or many useful things, okay, for a screw to be used for. Okay, so here, for example, in this book, they are using the screw to dig. Okay, so a screw changes a turning force into a downward force. So of course, when you dig, you are moving down. Okay, let's move to the last page, which is 469, and they are gonna talk about, sorry, it's not the last, before the last. I'm gonna talk about the wedge. Okay, the wedge, okay, is a simple machine that splits object apart. Okay, so whenever you think about the wedge, for example, like here, they give an example of the wedge as the axe. You know the axe? So whenever you use a machine to cut something, okay, and you have to know that this machine, there is nothing moving in it. Okay, it's fixed from all the sides. That's why it's called simple machine. So this simple machine is used to cut the wood. Okay, so whenever you cut the wood, you are splitting apart 2 pieces or many pieces. So when you split apart things, it is called a wedge, or you are using a wedge. That's it for simple machines. Let's go to the last page now, which is 470, and I'm gonna talk about the compound machines. Compound machines are when 2 or more simple machines are put together. Okay, take a look here at the scissors. They put, where you put your fingers inside, it's like the lever, because one goes up and the other goes down, with a fixed center, which is called the fulcrum. And they mix together with the lever, the wedge, because here the cutting thing happened, or the splitting apart happened. So the lever with the wedge makes a scissor, okay, which is a compound machine, okay, because we are using 2 simple machines together. The last example here, it's called the can opener. The can opener, if you take a look deeply about the can opener, you can see that they use the lever, the wedge, and the wheel and axle. Okay, here where's the lever, it goes up and down with the center, okay, and the wedge here where it cuts the thing that you're gonna up the can from the top. Okay, and here it's the wheel and axle. It rotates and rotates around something that is fixed. Okay, so here they use the three simple machines into one compound machine. Okay, that's it for this lesson. Please don't hesitate to ask. Thank you. Good morning, grade 3. I'm gonna move to chapter 12, lesson 1 in the science subject, and it's gonna talk about the lesson heat. Let's please all together open page 480 and let us start defining the word heat. Heat is the flow of energy between objects. You know that before I talked about when you rub your hands, and when you start rubbing your hands together, you might feel that your hands are getting hot. Why their hands are getting hot? Because you are making energy between them. Okay, so the flow of energy between objects will cause something called heat. So heat can travel through solids, liquids, and gases. Let me show you examples. Here I got how heat can flow through solids. If you burn coal, okay, the heat that's coming from the fire will cause the coal to be very hot. Okay, so the heat is being transformed or transferred from the fire itself to the coal. Coal is classified as solid stuff. So the heat is being transferred from the fire to the coal. This is the case of how heat can be transferred through solids. Now I'm gonna show you how heat gonna be transferred or travel through liquids. Let me show you here. If you take a look at the at this thing here, okay, here I have a pot with water inside it and fire under it. The fire is the source of heat I'm using here. So the fire is giving heat to the metal pot. So here from fire to the metal pot, it's between solids. Or heat is being transferred, okay, to solids. Then this solid will transfer or will travel the heat from the pot to the liquid itself. Okay, so here the heat, okay, will also travel to the liquid that is inside the pot. Now I'm gonna show you an example how heat can be transferred through gas. You know that we have gases all around us, right? In the sky and in the atmosphere. So here the sun is giving her its radiations of heat. Okay, the heat that is coming from the sun will warm up the gas that is surrounding us. So the gas here get warmer as the sun gives much heat. Okay, so that's why in the summer you're gonna feel that the air has the air is much warmer than in the winter. Okay, now no matter what it travels through, heat always flows from a warmer object to a cooler one. As I said before, I will show you here the example of the boiling thing again. Okay, so they said that heat will be transferred from the object that is more hot and more warmer to the object that is cooler. The fire will give heat to the warmer pot, so to the cooler pot, sorry. So the fire will give heat to the cold stuff, okay? This coldest pot will turn into warmer stuff later after the heat is traveling to it, okay? So please, you have to remember that heat travels through or heat travels from the warmer thing to the cooler thing. So the cooler thing gets hot later on. Now, what are the sources of heat? We're gonna talk about the main source of the heat, which is the sun, which warms our earth, okay? So source, the meaning of source is the thing that gives us something, okay? So the sun is the source of energy as heat, okay? So without the sun, our planet would be very cold and we can't survive it, okay? Another examples of source of heat, like fire, like light bulbs, stoves, and anything you get in mind, you have it in your mind that gives us heat, okay? Now let's move to heating objects. Some objects heat up faster than others. What does this sentence mean? If I think about it, for example, whenever you go to the beach, you're gonna feel that the sand is very hot and you could barely stand on it. As you reach the water is not that hot as the sand. So some things heat up faster than the others, even though they are receiving the same amount of heat, okay? Let's please turn together to page 482. How does heat affect matter? We all know that anything around us is made up of tiny particles. Particles are things you cannot see by your naked eye, but they are inside the things around us. Take an example of liquids, okay? Liquids can be hot or cold, right? So whenever the thing or whenever the water is hot, there is something inside it called thermal energy. So the energy that makes them move is called thermal energy. So whenever the liquid that is inside the cup here, it's very hot, the particles inside this liquid starts to move and move and move, okay? So to show you that the liquid that is inside the cup is very hot. So whenever the liquid is very hot, there is a moving system of the particles inside this liquid, which is called a thermal energy. Okay, so whenever the particles starts to move, there is something inside you cannot see, of course, but you're gonna, if you study the particles, how they're gonna move, you're gonna call it thermal energy. So heating matter increases how much thermal energy the particles have. As much as you give this cup heat, okay, the thermal energy gonna increase. As much as you lower the heat, okay, the thermal energy will start to slow down, okay? All the particles will start to slow down, okay? They will not move quickly. As you see here, the particles are running away each other. In cold things or cold liquids, the thermal energy is very low. That's why the particles are sticking to each other and they are barely moving, okay? So temperature Of course, you know its temperature. Temperature is how much hot or cold something is. So, whenever they ask you about how much cold or hot something is, you're gonna talk about temperature. Now, the more thermal energy an object has, the higher its temperature, and this is what I said before. As you give more heat, the thermal energy will be bigger. Okay, so more heat, more thermal energy. Okay, let's move to page 483. So when heat flows into an object, the object gains thermal energy. They are just repeating what I said before. So as heat flows into an object, we're gonna have thermal energy. Okay, and when we have more thermal energy, its temperature gonna increase. So its particles starts to move faster, and they start to move away from each other, so further apart. The object gets bigger or expands. So this is a new idea. Whenever something gets more heat and starts to get more thermal energy, the object itself gonna expand or get bigger in size. Take a look here on a dry place. This is a dry land. Well, of course, you know that on a dry land, it is dried because of the heat, okay, of the sun, okay. So because of this land, it's very hot. The land will get dry and the land will get very hot. So when the land gets very hot, the thermal energy in the land gonna get bigger. So when the thermal energy gets bigger, the particles gonna move and move faster, okay? And when thermal energy gets bigger, the temperature will increase. So the temperature of the land here, it increased and increased and increased until this land starts to expand. How can you know that this land expands? From the cracks? The land starts to crack and get away from each other because the temperature of this land is getting or is increasing, okay? So now the opposite idea here, when the temperature decreases, okay, the particles will move slowly, okay, and the object may get smaller or contracts. So we have two words, expand and contracts. Expands when they get more temperature or more thermal energy. When they lose the temperature, they will contract or they will get smaller in size, okay? There is a tool that is used to measure the temperature. This tool is called the thermometer. I know that you know it. Thermometer has, it looks like something, a tube that has a liquid inside. This liquid will increase as the temperature increases, okay? And it will lower down as the temperature starts to decrease. So when the temperature of the liquid increases, the liquid will expand up, okay, will go up. And as the temperature decreases, the liquid inside will contract, okay? This explains the theory that they talked about expanding and contracting, okay? Now, let's move to changing state. I know you know all about changing state, and you know when I heat up an ice cube, the ice cube will change from solid to liquid. This is something you already know. So, heating ice cubes, okay, will change their state from being solid state into liquid states, okay? And vice versa, whenever I decrease the temperature for the water will get into another state which is solid, okay? The same thing for water. Whenever you increase the temperature for water, they will evaporate and change from being in the liquid state to the gas state, okay? This is something you already know. Let's move to the last page, which is 484. And page 484, the question is, how can you control the flow of heat? You have to know something, that heat moves easily through some materials more than others. The thing is that whenever you give heat to objects, you are giving them energy. This energy is being passed from the source of heat to the object you are giving the heat to it. Some objects, they are called conductors. Conductors to heat are materials that heat moves through them easily, like the pot, as I showed you before. Usually materials that are made up of metals are good conductors for heat. So metals here, they will take the heat from the source of the heat that is given, okay, and the heat will get through them easily, okay. And materials that they do not conduct, or they do not let heat pass through them easily, okay, or they pass heat through them but in a lower amount than the conductor heaters, okay, we call them insulators, okay. So heat insulators, they do not conduct or they do not pass through them heat, like wool, cotton, fur, any kind of materials like these, okay. That's why they make materials that you can hold hot stuff. They are made up of wool or cotton, so you can hold with them the hot thing. So please, you have to know that conductors, they move through them heat. Insulators, they do not move through them heat, or they do not move through them heat easily, okay. That's it for this lesson. I hope that all the details have been explained clearly, and if there are any questions, please don't hesitate to ask. Thank you.